introduce myself. I'm Steve Stedman, and I have with me Kiana Bergsma.
Hi there.
I'll be presenting on SQL join types today, and then Kiana will be assisting with some of the administrative things like giving away the prizes at the end of the presentation. A little bit of background here on myself. I've been using SQL Server for just over 31 years now, and first got started back in 1990. And done a lot with SQL Server along the way. I've created a program called Database Health Monitor that I give away for free that you can download at databasehealth.com. A couple years ago, I created the Database Corruption Challenge to teach people a lot about database corruption. And also, I blog regularly at stevestedman.com. And for my day job, I work at Stedman Solutions full-time with a team of 4. And we do SQL Server consulting, everything from managed SQL services to corruption repair and performance assessments, things like that. We'll have a prize giveaway at the end, right before the Q&A section. And what we'll be giving away is 3 daily checkup subscriptions. And what this is a product we make where you run it on your SQL server, it does a check and reports up to a cloud-based server of the status of things. It doesn't give away any private data or anything like that, but it reports the status of things. And then at the end of, and then you get reporting on it that shows you what's going on with the SQL Server and what kind of things need attention there. Also, just a reminder, you can download the join types poster at stevestedman.com. And this is a poster I created a few years ago that just sort of shows how all the different joins that we're going to be covering through this presentation are done. It's handy to print out and keep on your cube wall or near your workspace. So to get started, some humor to start with here. A SQL query walks into a bar and sees 2 tables, walks up to them and says, "Can I join you?" Ooh, bad SQL joke. But one table responds and says, "Only if you're willing to commit." That one goes off much better with a live studio audience rather than
Right.
with everyone muted. So
Everyone's muted.
So one of the things that comes up with when you're working with SQL Server is a common interview question. And I've seen this asked, and I've even asked it when I've been interviewing people, as a way to sort of get an understanding of how well someone knows T-SQL or knows how to write queries. And the interview question is, can you describe to me the difference between an inner join and an outer join? And having been on the company side of the interview table with candidates on this, it's really been interesting to see some of the responses of what people have tried to do when they really don't know it, but they're afraid to admit they don't know it. So part of this presentation is that by the end of this session, you will be able to ace that question, probably know more about it than the person asking the question if you ever get asked that on a job interview. So some of the things we're going to cover will be simply a basic select statement, because that's the fundamental thing that we'll be using for doing all of these joins. And then all of these joins are different ways of connecting data from different tables. So in SQL Server, it's a relational database. And what makes that relational is the relationship between different tables. Table 1 has some linkage over to table 2 or table 3, and we're going to use those linkages to bring data together in different ways. With that, we have things such as an inner join. We have left outer joins, right outer joins, left outer join with exclusion, right outer join with exclusion. We have what's called a semi-join or an anti-semi-join. There's cross joins, full outer joins, full outer join with exclusion, cross apply, and outer apply. And technically, cross apply and outer apply aren't really truly a join, but they work a lot of the same way, similar to a join. So we'll take a look at those, and then we'll take a look at how to use multiple combination of joins. Now, one of the things is when you first start looking at a query is you really want to understand the data. So what we're going to be using is we're going to be using Venn diagrams. So if you can see in this screen, we have 2 tables, table 1 and table 2, and they're just shown as 2 circles up in the corner in green that shows that when we select star from table 1, we're going to get everything out of table 1. When we select star from table 2, we're going to get everything out of table 2. There's no overlap in this example of this Venn diagram between the two tables because they're not connected. And this is a good time to jump over to my sample database right here. And what we've got is I've just created a database called Query Training. And in there, a couple of tables. Table 1, which just has an ID and a name. And then it has a foreign key column off to a favorite color table and a favorite food table. And these are not actually foreign keys, and that there's no foreign key relationship there. It's just that the ID from this, it's not an enforced foreign key. It's just simple for the example. Second table is the favorite color table. And then the third table is the favorite food table. And it's kind of not very exciting data, but it's a way to look at some real simple data in a way that we can use it and work on these joins. So all I've done is just recreated the database, created the tables. Now I'm going to fill it in with some information here. Don't need to look at that too much, but what we're going to do is go look at what's in the tables. So when we select from table 1 or table 2, what we get in table 1 is a bunch of people's first names. There's me, Steve, and a handful of other people. And in there, they have a link to a favorite color table. So favorite color of 1 is over here, and it maps to the ID of 1. And one of the things when we look at joins is that different things happen when you have multiple items in the other table. So this is not an enforced primary key here, which it would be nice to have. But what we ended up with is we have two colors here, red and indigo, that both map to an ID of 1, for instance. But then all the other colors, there's just one color that maps to an ID. Green is 2, so on. As we go through here, we're also going to take a look at table 3, which has the favorite foods in it. It's pretty simple: pizza, burger, and sushi. So as we go through this, what we're going to be doing is building queries that are based off the relationship of those 3 tables. And those 3 tables are also outlined and shown on the join type poster if you happen to download that at my website at stevestedman.com. But what we're going to do is look at how do we bring the data together in different ways. So basic select, simple. We're just pulling everything out of a table, or you could filter it to a specific set. But next, we're going to take a look at an inner join. And what an inner join does is it connects data between 2 tables. In this case, we just say table 1 and table 2. You put your real table names there, of course. And I've aliased them as T1 and T2 so that we can use the short name of T1 and T2 instead of the table name. And then what this does is it returns only the rows that match on the join predicate. The join predicate is what people sometimes call the on clause. And this is specifying an inner join. It's also known as just a plain join. If you use the word inner join or just the word join, it means the same thing. It's matching on those, and it's only showing you the things that are an exact match. Now, if you're watching and you're thinking, oh, this is a little bit boring at this point, we're just getting into it. This is the simple stuff. We're going to get into the more interesting stuff here real quick. But the join predicate, like I said, that's what's known typically as the on clause. Join predicate. It's what specifies the relationship between those 2 tables. And why is this important is that in a lot of tables that you may work with, you've got lots of different IDs. And if you don't understand what ID signifies the relationship between table 1 and table 2, well, you may not be connecting them on the right information. I remember years ago, I was working with a report developer who didn't understand the naming of the different keys between the table and ended up joining on the wrong key, which led to just completely bogus data showing up in the reports that were built off of that. So that's why I always want to talk about here is understanding the relationship. And if you don't understand the data and how the tables work well together before you try and write your query is not going to probably work very well. So we'll flip back over to Management Studio here. We've looked at our 3 tables. Table 1 is the people, table 2 is the favorite colors, and table 3 is the favorite foods. Probably everybody has a much more exciting database than that. But let's take a look here, and we're going to take a look at inner join. And when we run this, we're going to be joining table 1 and table 2, and we're joining the favorite color from table 1 over to the ID from table 2. And when we run that, you can see that the first columns here, those all came from table 1. And then the ID and the favorite color over here came from table 2. And you can see that there's 2 people here whose favorite color was 1, which was Steve and Fred. And in that example, they actually had 2 favorite colors because there's an error in the data. And we all know that in real databases, you get mistakes made, but I wanted to use this for the example where there's two colors mapped to the ID of one, of red and indigo. And that shows that because there's two rows with an ID of one in table 2, it ends up duplicating out these rows when it does an inner join. So some people look at it and they say, well, I've got exactly n rows that are a match. Why am I seeing more than n being the number of rows showing up in the result set? And sometimes they'll match on multiple things, like the red and indigo being shown there on the join. Now, what you also notice is there's a couple people who got left off from that original list. If we scroll back up and take a look at table 1, we can see there's Johnny and Karen down here at the bottom who don't have a favorite color. Their favorite color is null. Well, they got missed when we did the inner join because there's no way to link them up there based off of that with an inner join. So here it's just your basic select statement. You use the word inner join, and then the alternate syntax is just to use the word join rather than inner. Now, I like to use the word inner join because it's explicit. It makes it so that the next person reading it is aware that you intended to do an inner join here instead of thinking you were doing some other type of join and you just might have forgot the keyword. So when we run this, just with the join rather than the word inner join there, we get the exact same result set that we saw with the inner join above. Inner joins are by far the most common join type that you'll probably do in SQL Server, and it's because it's probably the most fundamental way to join data between two tables. Now we'll take a look at a left outer join. And when we look at this, a lot of the time you get confused as to what left means, and then we're going to take a look at a right outer join. So what this means is, and the only thing I've changed in here is in this query between this one and the previous one is I changed the word inner to simply be left outer, and it's joining the same tables. And what it's going to do is it's going to return all the rows from table 1. And if there's a match in table 2, you will get the match. Otherwise, the table 2 columns will be shown as nulls. So for instance, in the example we looked at a minute ago, there were two people, Johnny and Karen, who did not have a favorite color, and they got left out when we did the inner join. But when we do this with the left outer join, they get included. And we'll take a look at that in the code right now. So all I did was change the word inner from the above query to just say left outer join. And you can see that the first batch of rows that we got back in the result set here, the ones I've just highlighted, are the exact same thing that we saw when we did the inner join. But the two at the bottom, Johnny and Karen, who were missed on the inner join query, got included because of the use of the left outer join. And with that, because there's nothing they matched in the favorite colors table, the columns that come back from the favorites colors table just get simply put in there as null. That can be handy, for instance, if you had a list of employees, let's just pretend that's what this was, and you were going to print up like company shirts and you wanted to get their favorite color on their company shirt, you could run a query and maybe the answer was if somebody doesn't have a favorite color, they get a green shirt. In that case, if you did an inner join, you would have missed Johnny and Karen and they wouldn't have got their t-shirts printed this way. Where if you do the left outer join, you can include those people even though they don't have a favorite color. And I've seen so many times where somebody will have a set of data, they do an inner join, and then they wonder where are all these other people or why are these people missing? Well, it's because they did an inner join to something that was an optional table or optional field, and they got dumped out of the result set where the left outer join would allow them to be included. Next, we have a right outer join. And the difference between a left and a right outer join is that it returns all the rows from table 2 instead of table 1. And if there's a match, it shows the same thing you would see on an inner join. But if there's not a match, it shows the table 1 columns that are shown as nulls. And all that we changed here was the word left outer to be right outer. And what left and right implies is that the first table is considered the left table. That's table 1 in this case. And the second table is considered the right table. That's table 2 in this case. Let's take a look at how that query differs. Scroll down, and the only thing that changed between this one and the previous one is the word left was changed to right. And you can see now the bottom set of results down here is exactly the same as what we saw in the inner join, but we have these three colors over here, pink, mauve, and orange, that are not mapped to a specific user. Now, Those got overlooked in the previous two queries because they were not included in the inner join or the left outer join. But with this, if you wanted to say, give me all of the colors and show which people have that color as their favorite color, the right outer join, which we've used here, would be more useful in being able to see the entire list of the colors. Now, one of the questions that always comes up is, why a right outer join versus a left outer join? Couldn't you just reverse the order of the tables and always use a left outer join? And if you wanted to do that, you certainly could. You could go and grab this query and switch table 2 and table 1 around and make this a left outer join, and it would absolutely work the same way that we just did with the right outer join there. The columns might show up in a little bit different order because of which one's first or second, but that could easily be managed by specifying the columns in your query. But where it gets interesting is not just when you're joining 2 tables, but when you're joining 3 tables or 4 tables or 10 tables, sometimes that left outer join is going to be the only way to get what you need based off of all the other tables in the query. Or sometimes the right outer join is going to be the only table to achieve what you're looking for there. So they're basically the same concept. It's just determining which table is going to be treated like the inner join and then which table is going to have those extra nulls added in, depending on the left or the right side. Okay, so there's this thing that's called a semi-join, and a lot of people may argue it's truly not a join, but what it's doing is it's using the exist clause in your query to just find those things from a specific table that match. So this is similar to an inner join, but it's only returning columns from table 1. The other difference is with an inner join, you can get duplicates, and that's specifically why I put in those duplicate colors there on the favorite color, is that you can get duplicates. And in the case of ordering t-shirts, well, you might end up with one person getting 2 t-shirts because they had 2 colors. Not in this case. So what this does is it will only return each row from table 1 once, and it will only show those that have a match in table 2. And semi is Latin for half, so a semi-join is like a half join, and we'll take a look at how that one works. So here's the semi-join, and we're selecting everything from table 1, and if we just run that, you can see that there's all the people, there's all 8 of them, but only where there's a value that exists in table 2 that matches the favorite color. So when we run the whole thing together, we get all of those people who had a favorite color, but not duplicates of them. Now, you might look at this and say, well, couldn't I just change this to say, instead of where exists on this subquery, I could say where that favorite color foreign key is not null? You could, but the difference is this is actually going and confirming that it exists in that other table rather than someone who might have put a number in there that doesn't exist in that table. Next, after the semi-join is what's known as the anti-semi-join. And this is simply changing the exists to a not exists. And what you're doing is you're saying, give me all of those people in table 1 that don't match up with table 2. So this would be the way, if we're looking at the favorite colors, to go in and say, show me all the people who don't have a favorite color. And there we have Johnny and Karen. And if you're really trying to order t-shirts for your entire company, you might go push them to pick their favorite shirt color and put it in there so they get a shirt ordered for them. Okay, one thing I'm going to back up to that I zoomed past here was multiple outer joins. And that's stepping back to the previous slide where we're saying select from table 1, inner join table 2 on favorite color. But then we're also going to say, that was a right outer join. Then we're going to say left outer join table 3 on the favorite food. And we'll take a look at the combination of multiple queries there. And you can see now, if we look at this list, those are the people who have the favorite colors. Only one of them has a favorite food. What we're getting is that of the people who have a favorite color, only one of them has a favorite food. And we'll come back to this in a little bit. But one of the things is that what happens if we specify an outer join without actually putting a left or a right outer join? Well, that's not valid. That's invalid syntax because you have to specify a left or a right when you're doing the outer join. There's a question that popped up that I'm going to answer while I'm right here. What does select 1 mean on your subquery when you're looking at the semi-join or the anti-semi-join for that matter? Well, what that means is just selecting something back. You could say select star, and it would behave about the same way. Or you could say select ID, and it would return, it's just selecting some value back. And here I'm just selecting the value 1 when it exists. Now, the difference is depending on what you're selecting back, this inner query might have to do more work to find all the columns that you're selecting back just to determine if it exists. So hopefully that question is answered. I know I said I would hold them to the end, but that one I just noticed and it was a good time to answer it. So next we have the left outer join with exclusion. And this is one of my favorite ways to find missing data. And what this is going to do, it's just like the left outer join we did before, but we're saying where the ID from table 2 is null. So that's going to say it's going to return all the rows from table 1 that don't match in table 2. So let's take a look at that. Left outer join with exclusion. If I highlight just the first part of it without the where clause, that's our basic left outer join that we did before, where we get everybody, including those who have favorite colors and those who do not have favorite colors. And if we wanted to just get a list of those people who don't have a favorite color, we can say where the ID is null, which that means this ID column, and it should only return Johnny and Karen in this case. There we go. So that's another way to look at everyone in table 1 who's going to be out of luck because they don't have a favorite shirt color or favorite color when they're getting t-shirts printed. Very handy when you're doing data validation or trying to fill in blanks to be able to go through and find out who's not matched there. Now the right outer join with exclusion, exact same thing. We're just throwing in a where clause that says where table 1's foreign key is null, and it returns all the rows from table 2 that don't match to table 1. So this one, the right outer join with exclusion. And again, I'm just going to run the first part without the where clause first. And when we run that, we can see, whoops, highlight the right part. We can see that we get back exactly the same thing we saw in the right outer join before. But what we want to do is find the 3 colors that aren't chosen by anyone. And that comes back as pink, mauve, and orange. So that would be the colors that you do not want to print any t-shirts for people. You don't want to have any t-shirts made for people of those colors because nobody seems to enjoy those colors. Next, we have the full outer join. And this one can get interesting because this is kind of like saying, let's do both a left outer join and a right outer join at the same time. So what it's trying to do, it's matching up every row from both tables that match, just like an inner join would, but then it's going to show all of those that are in table 2 that don't match table 1. And then it's also going to show all of those from table 1 that don't match table 2. So let's take a look at the full outer join. Just select. So all we've done is we've taken the left or the right outer join and changed it to a full outer join here. We run that and we can see the first rows that all match up scrolling down here. Those are the same that we saw on an inner join. These next 2 are the ones that we saw on a left outer join with Johnny and Karen not having a favorite color. And then the last 3 are those that we saw on a right outer join where pink, mauve, and orange were not colors that were selected by anyone. Now what we can do is say, do a full outer join with exclusion, and that's shown like the left outer join with exclusion or right outer join with exclusion, but we have to say where the different values are null just to find those that are in table 1 or table 2, but not matched up between the 2 of them. So here's select star, same as the full outer join we just did above, but we throw in where this favorite color is null and table 2's ID is null. And it shows me all of those that don't match. So if this was something different besides like colors or and people, maybe you had people and instead of colors, you had desk locations in an office, and you were trying to find all of the desks that were available and find all the people who did not have a desk assigned, you could use this full outer join with exclusion to get the list and then figure out, well, this person has to go sit at that desk and go through the list and work it out that way. This one you don't use very often, but when you do come up with a reason to use it, it can be super handy compared to other ways of trying to get at the same information. Next, we'll take a look at a cross join. And if we look at the cross join, this is the same Venn diagram that I showed for the full outer join, which shows everybody from table 1 and table 2. But the Venn diagram doesn't do a real great job of representing this one. But what's different here is that there's no join predicate or the on clause. and there's no where being specified. So you're simply saying, take every item in table 1 and match it up with every combination of items from table 2. So there is no logical joining here, but this is useful. I've used this before when I've been filling in like test data in a for load test situation, where you put in one table, you put a bunch of first names, in another table, you put middle names, in another table, you put last names, and then you do a cross join and you get every combination of all those names and quickly populate a table. So we'll take a look now at the cross join. And I just want to say, be careful with this one, because if you're doing this on big tables, you can get some really gigantic result sets, because what it's going to do is it's going to take the number of rows in table 1 multiplied by the number of rows in table 2, and that's how many results you're going to get. So you can see here we got 72 rows because I think we had, what, 8 times 9 different combinations. So we can see here that for Steve, which had a favorite color of 1, it mapped me to all colors. And then for Aaron, who had a favorite color of 3, it mapped Aaron to all colors. So it's just a way to show a combination of everything in the 2 tables. Again, this one's super useful if you're trying to crank out a huge amount of data to fill in a table for testing purposes. So next, we're going to take a look at the apply. And this is not technically like an ANSI SQL standard, but it's Microsoft's extension. It was originally intended to be used with table valued functions, or functions that return a table as their results. And it allows you to invoke a table valued function for each row returned by a outer table expression of a query. Now, prior to really learning how the apply worked, I'd found different queries that people had wrote on the internet and copied and pasted them and just wondered, what is this apply thing and how is it working? Well, we're going to take a look. It's basically like a correlated subquery, in that the values from the outside are applied and they can be passed to the inside of the query. So let's take a look at an example here. Instead of joining from a table to another table, you're joining from a table to a correlated subquery or a table valued function. And it's like an inner join between a table and a function. So let's take a look at how the cross apply looks. First, we're going to take a look at table 1. And we remember in table 1, we had a list of people and we had some favorite colors and we had some favorite foods. We'll just ignore the food part now because we're simply looking at the favorite colors. And what we're going to do is we're going to say select everything from table 1, but instead of an inner join or an outer join, we're going to say cross apply, which is going to act like an inner join, but instead of inner joining to a table, we're inner joining to a correlated subquery. And what makes this a correlated subquery is that it's a query inside of parentheses that's being referenced, but what correlates it is this T1 favorite color value is being passed in from the outside here. So effectively, if you have, let's say, 10 rows in table 1, this subquery will be called 10 times with the parameter of that favorite color from table 1 being passed into it each of those 10 times, bringing back a slightly different result set, and join those together into a table. And what it looks like is this. Now, this happens to be the same thing that we got when we did an inner join, but, and if we look at it right here, we look at an inner join, and yes, we do see the exact same thing, but it's a way of being able to not just join to a table, but being able to join to a subquery. Now, technically, instead of a table 2, you could just say inner join to that subquery and specify the join predicate, and that would work. But where this gets different is when you need to use a function. So what I'm going to do is I'm going to create a function called get favorite color multi, where it just takes in an ID and it looks up their favorite color and returns that favorite color. And then to test that, we'll say select star from get favorite color multi for 2. And it shows that the favorite color of 2 is green. And if we change that to 1, we would see that the favorite color was both red and indigo because of that data inconsistency we're dealing with of 2 that have an ID of 1. So what we do here is that you could, instead of wrapping it like this with a select, you could instead pass in, just say select from table 1, cross apply, this function, table valued function, with this parameter, and for every row of table 1, it's going to call this function with this parameter and put that all together in a nice single result set. Let's take a look at that. Now, for something simple, like looking up the color between two different tables, that function's, there's not a lot of value in adding that. But oftentimes where this is handy is when you have access to a function that someone else has provided you, a table valued function, and with that, you may not have access to the tables or the data directly like some of the internal SQL functions, but you're able to run that and call that function multiple times and put all the results into one result set. So next, what I'm going to do is create a function, and as get favorite color, I'll just talk about that for a second. Basically, in SQL Server, there's performance differences if you have a single statement table valued function versus a multiple statement table valued function. This one is technically multiple statements because it has this insert and then it has a return. If instead we'd created it simply as it returns a table and it was a single statement, you get different performance based off of how those are written. And it may not make a big difference with a table the size that we're dealing with here, but when you get to larger tables, that can have a huge performance impact in what you're doing. But that was from a little bit more detailed presentation where we went into a lot more performance on this. But you can see that there can be different amounts of work being done, whether it's a single statement table valued function or a multiple statement table valued function. Okay, so we've looked at the cross apply, and here's an example of using cross apply where we're going to select from query stats. And this is one of those DM exec query stats, an internal system table that shows you all the different queries are running. But there is this function called DM exec query plan that will take a plan handle and turn that into SQL code. And the way we would use that is just change this to select star. When we run it, we get everything from QS as we specified there, but when we scroll over, we also get those that come from the query plan and get the plan handle, and we can see the entire plan details here that were not included in the original part. Without this cross apply function, what you would have to do is like take the results of that first query, dump it into a table somewhere, and then do a cursor or somehow iterate over the loop in order to process all those results and then put it all together as a result, where the cross apply just makes it easier to do it that way. Next, we have the outer apply, and this is a lot like, instead of an inner join, where it's going to be a lot like a left outer join between a table and a table valued function. And you may wonder, is there any equivalent to a right outer join? And no, it's either cross apply or outer apply. One of them acts like an inner join, the other one acts like a left outer join. And when we take a look at the cross or the outer apply, when we run that, before we were only getting those that matched up because it was treated like an inner join, but now we're back to getting Johnny and Karen, who are listed down here, who did not have a favorite color using that outer apply. And that outer apply can be used with a function, table valued function, or it can be used with a correlated subquery like we have here. Next, we're going to take a look at equijoins versus non-equijoins. And everything that we've looked at so far has had an equals in the join predicate or in the where clause. Well, I guess the where clause has just been null or is null or not null. But what's different here is instead of saying that we want to say where something is equal, we can join and say where something is greater than or equal to, or less than or equal to, or greater than or less than. And what that does is it makes some interesting queries. This is a hard one to find a good use case for, but it is something that can be used. So let's take a look. All we're going to do is do a join. And instead of saying equals, we're going to do a greater than or equals or a less than or equals. We run that, and it's going to say, give me everybody from table 1 and match them up to the favorite colors where the favorite color is greater than or equal to T2's ID. So in this example, Steve with a favorite color of 1 matched up to all the colors that had an ID where 1 was less or greater than or equal to the ID. And there's only 1 in that case. But then Aaron, who had a favorite color of 3, was matched up to all of those favorite colors that had an ID of 3, had an ID of 2, or had an ID of 1. Not very useful on the favorite color selection here, but there are certain cases that it might be interesting to do as well. So next we're going to take a look at a left outer join with the same thing rather than an inner join, but a left outer join with the non-equi style join. It's going to do the left outer join, but it's joining it where it's greater than or equal to. So that's where we start seeing the ones that don't match show up rather than those that just did match. Let me just run those two together and show that. So here the top one ends at Beth, and then the left outer join also includes Johnny and Karen, who have been our problems on the join based off of not having the favorite color that we've looked at earlier. And then you can also do the non-equi right outer join. And this is just with a less than rather than a less than or equal to. So this is saying, give me all of those where table one's favorite color, in that case of one, is less than the favorite color in table two. And you can see that throughout here, it maps to all of those. And if I threw on an order by name favorite color, what this is going to do is show me alphabetically here, Aaron, whose favorite color is 3, is going to be mapped to every favorite color that's greater than 3, or it's going to show every favorite color that 3 is less than it, technically speaking, from how that's phrased up there. Okay, not going to spend a lot of time on those, but it is something to know about and something that can give you some interesting results in specific scenarios, but also could cause some headaches if you're not familiar with them. All right, next I want to take a look at two inner joins. And what this is doing, this is just like the very first example we looked at where it just takes, it's joining and everything that's matching up between two tables is being shown, but it's throwing in a third table. And it's saying, give me everything. And there's a typo on this screen. This should, in the Venn diagram, it should show table 1, table 2, and table 3, rather than table 1, and table 3. But let's take a look at how that query works. And it's only going to return those people who have a favorite color and have a favorite food. And you can see there's only one person that has both. Beth, her favorite color is yellow and her favorite food is pizza. Now, if we just did the original part without joining to table 3, that would show all the people who had a favorite color. Or if we commented out the inner join to table 2, that would show all the people who had a favorite food, but joining them together, it shows all those people that had a favorite color and had a favorite food, or that matched up across all three tables. Next, we'll take a look at two left outer joins. And remember, the left outer joins show everyone from the first table, and it shows who they match on the other tables if they match. Otherwise, it shows nulls. So in this example, it's going to show everyone from table 1 matched up with those people, those things they match up with from table 2 and 3, or if they don't match, it'll show nulls. So here we only got one result back when we did the inner join. When we switch it over to a left outer join, we get more rows back. We get the duplicated rows for those people who had the favorite color with multiple colors of red and indigo, for instance. But then we see that we get Johnny and Karen who don't have a favorite color, but we do see that they do have a favorite food over here in the other left outer join. So this is kind of a way to say, look at everyone, not just those who are matched. And then you can get into any type of convoluted combination of inners and outers and left outers, and it can get kind of wacky. But using Venn diagrams can help kind of track down what's going on. So first we're saying, give me an inner join between table 1 and table 2, which is what's only going to show me this little piece in the middle here. And then a left outer join is going to say, match me up with table 3. But if table 3 doesn't have a match, just show nulls. So when we go and run that one, the inner join with the left outer join, first I'm just going to run the inner join. And you can see that's the list that we saw in the very beginning of the demo up top in this sample. And then when we do the left outer join, it's all of those same people from that original set that were inner joined. So the inner join got rid of Johnny and Karen, who didn't have a favorite color, but the left outer join brought in the pizza here for Beth, but left everyone else's favorite food as being null and didn't exclude them. Two full outer joins. Now this can get interesting. We have table 1, full outer join to table 2, full outer join to table 3. And if we look at the Venn diagram for that, it's going to be treating it like a left and right outer join between all of those tables. And you can see that the first batch up here is those that would have been caught in the inner join. And then you've got those that would have shown up with the left outer join to table 2. And then you've got the next batch is those that would have shown up with the left outer join to table 3. And then the final one, the sushi, which nobody has chosen sushi, unfortunately, because sushi is really good, but it's showing up in here because it's a full outer join. And if this had just been a left outer join, that sushi would have been overlooked. All right, so at this point, I want to take a look at a couple more examples here that are on the poster, but they're technically not in the presentation. So if we go back and look at table 1 and table 2 again, there's the concept of accept and intersect, which I've represented in the Venn diagrams on the poster, but they're technically not join types. What it's saying is give me all the IDs from table 1, but throw out all the IDs that are in table 2. And that shows up as null. And if we run it the other way around, give me all the IDs from table 2 that don't show up, and throw out all of those that are actually in table 1, we can see that IDs of 4, 6, and 7 are missing. And because of that, that maps to, what was it, orange, mauve, and something else that were not chosen. So it's sort of another way to get at similar type of data that we were seeing on the left and right outer joins with exclusions. Now, this is one of those things when we do corruption repair, I like to compare results of tables before and after, and you can use the except statement like this to say compare everything from one table to everything from another table and see what the results look like. Intersect is similar, but instead of saying throw out specific rows, it says only show me those rows that match up. This is more like an inner join. And then union is sort of like the full outer join, which says give me everything from both tables and including the null, and it gives all the IDs there that are being used. And if you want to include duplicates, you can use the union all to bring those together and see that some of them are accessed more than one time. The union all is way more efficient than the union itself, because when you just use straight union, it has to sort the entire result set to throw out the duplicates, whereas the union all doesn't. Anyway, just a little bit different way of looking at some data there that's also included in the join types poster, even though they're truly not join types. So now if we get back to the question of, can you describe to me the difference between an inner join and an outer join? Now, if you were asked that on a job interview, you might say, well, what type of an outer join? A left, a right, or a full outer join, or a left outer join with exclusion or without exclusion? You might say that inner join includes those items where the join predicate is an exact match, or another way of saying that is the inner join only includes those things that match between both tables. You could say that the outer join, a left outer join, returns everything from the select table. And if there's a match on the join table, then it shows it. If it's not a match, it shows nulls for those. Same thing flipped around backwards with the right, where it says if there's a match in the select table, then show it. Otherwise, it shows nulls. You could say that a full outer join, everything from both sides, and it puts in nulls where there's not a match. Or you could probably go into much more detail on these, but I would just be careful. There's a lot of information here, and most people who I've seen ask this question on an interview truly don't know the difference. And usually what they're looking for is that an inner join shows an exact match and an outer join shows those things, including those that don't match. But now you know far more about that than most of the people asking those interview questions. So we've covered the basic select, we've covered the inner join, which brings across everything that matches between two tables. We've covered the left outer join, which says include everything from the select table, and then if it's a match, show it from the join table, otherwise include nulls. The right outer join, which is the complete opposite of that. The left outer join with exclusion, which says throw some of those away based off of a specific where clause. The right outer join with exclusion, which again says throw some of those away based off the where clause. The semi-join and an anti-semi-join, which are ways of using the exists to determine which rows you need to get back, or the not exists. We've covered the cross join, which is effectively the Cartesian product between both tables. It just says, give me everything from this one matched up with absolutely everything from the other table. We've covered the full outer join, which is like doing a left and a right outer join combined. We've covered the full outer join with exclusion, which is where we're using the where clause in that full outer join to throw certain rows away. And once you think of it that way, these with exclusions, you'll find out that you'll end up using them all the time now that you have that concept. We've covered the cross apply and the outer apply, which are effectively ways to do an inner join or a left outer join against a function or a correlated subquery. And we've got multiple combination of joins and where we can do multiple inner joins, multiple left outer joins, multiple right outer joins, or any combination of such. Occasionally you'll get somebody will ask you to look at a query and say, what's this query doing? And you'll look and you'll say, oh, there's 17 inner joins, there's 18 left outer joins, and there's 6 right outer joins, and no wonder it's not working. We've got to go through and sort out what it all means. Some of those can get pretty complex and make it hard to track down, but understanding what all of those different join types do really makes it so you can understand what the questions or what the query is doing. Some more examples. I've got a lot of examples on this at stevestedman.com. You can download the join type poster from there. There's the company website at stedmansolutions.com if you ever need our help, or you can get me Twitter at SQLEMT, or you can email me to Steve at Stedman Solutions. And email is really the best way to get a hold of me there. Thanks for attending, everyone. I think we'll wrap it up at this point. Have a great night.